Welcome back, everybody, to the second session of our three-part webinar series on collaborative robotics. If you joined us for the first session, you'll recall that we covered the basics of what cobots are, how they differ from traditional automation, and why they're becoming a go-to solution for manufacturers of all sizes. For those of you who are just joining us for the first time, I'm Stephanie Calloway with Doosan Robotics. I've met a lot of you in person during my travels up there with IAS, so nice to see you all. Thank you for joining us. And I'm also joined by Matt Langdon, one of our talented and experienced application engineers here with Doosan Robotics. We're both based in Dallas, Texas. And also, before we begin, I'd like to take a moment to thank the Manufacturers Association of Maine for giving us the opportunity to speak with you guys and share some insights into collaborative robotics. Their commitment to supporting and growing the manufacturing industry in this region is really, truly commendable. And we're excited to just be a part of that and have the opportunity to speak to you all today. So. With that, today's session, we're going to take a deeper dive into real-world applications of cobots and explore the different ways businesses are successfully integrating them into their operations. And here's what we're going to cover. We'll do a quick recap of what we discussed in part one, which was our introduction to cobots. And then we'll also take a look at industries that have adopted cobots and why they've become such a valuable tool. We're also going to highlight some specific tasks that cobots are performing across different sectors. And then last, we'll share some real examples of businesses that have successfully implemented cobots at the impact that they have seen. And also, as always, we'll do a Q&A at the end of this session. So if you have any questions, please feel free. Up at the very top, you'll see a Q&A box or a chat box. Drop anything in there to the side, and Matt and I will get to those at the end of it and answer what we can. So, quick recap of part one. We did a very high-level overview of what collaborative robotics are. We discussed how cobots differ from traditional industrial robots, focusing on their ability to work safely alongside humans without the need for extensive safety guarding. So again, you may recall that picture that we had from the very first session where there was a big industrial robot with a bunch of fencing around it, and then a cobot with a guy welding actually touching it. So that's really, when we break it down, the most basic difference. Cobots can easily be implemented in your workspace alongside humans. They're very safe. We also highlighted some of the key benefits, including ease of programming, flexibility in deployment, and the ability to enhance productivity while improving workplace ergonomics for your staff. And then lastly, we covered some applications where cobots are currently being implemented, and we're going to dive further into those today. So if you didn't get to see that part one, as Mike mentioned earlier, they did record that, and it is on the Maine Association of the Manufacturers Association of Maine YouTube channel. So you can catch that there. All right. Now that we've recapped the basics, let's talk about where cobots are making the biggest impact. One of the things that makes cobots so exciting is their versatility. They're being used across a wide range of industries, helping businesses improve efficiency, quality, and worker safety. One of the main places that we see this is in manufacturing and assembly. Whether they're handling small part assembly like screw driving, packaging, cobots are taking on repetitive tasks so workers can focus on more complex, high-value work. You know, you have that staff. You don't want them just standing there all day long, loading and unloading something. So let's refocus them in a place that's more rewarding, where they can have more satisfaction out of their job. And because cobots are easy to program and redeploy, manufacturers are really liking the flexibility that they provide, being able to be moved around their shop floor. In highly regulated environments like pharmaceuticals and medical applications, where precision and consistency are critical, that's where cobots really do shine. From lab automation to medical device manufacturing, pharmaceutical manufacturing, cobots help maintain quality while also improving efficiency. Plus, their ability to operate in controlled environments makes them a really great fit for this industry. Another area that's seen tremendous growth over the last couple of years is logistics and warehousing, where cobots are helping businesses with pick and place, order fulfillment, box erecting, palletizing. With e-commerce and supply chain demands at really an all-time high right now, companies are using cobots to keep up with demand while reducing physical strain on workers. Matt's going to dive into one of these real-world applications later on, specifically palletizing, which is huge right now for collaborative robots. And then finally, we have the food and beverage industry. We see, obviously hygiene and safety are top priorities here, and cobots are stepping in to handle tasks like quality inspection and packaging, reducing human contact and ensuring consistency. You might think about it like French frying or frying chicken or something like that. It's kind of a dangerous job. It relies a lot on timing for individuals, so a cobot can step in and fry your French fries to the same temperature, to the same length of time every single time. So it's really an ideal fit for that sector. And that's really just starting to blossom in the United States. So across all of these industries, cobots are helping companies increase efficiency, improve safety, and enhance precision, all while really maintaining flexibility in the production processes. So let's talk about some common cobot applications. No matter the industry, cobots are really stepping in to handle tasks that are repetitive, require precision, and are physically taxing for human workers. We refer to them as the 3Ds: dull, dirty, and dangerous. Take machine tending, for example. Many manufacturers use cobots to load and unload CNC machines or injection molding equipment. This not only keeps machines running efficiently, but it also allows workers to focus on those high value tasks that I mentioned earlier, more rewarding than standing in a machine all day doing the exact same process. Palletizing and packaging are another huge area where cobots are shining. If you've ever worked in a warehouse or manufacturing facility, it's physically exhausting to pick up a box, put it on a pallet all day long, same repetitive motion. So cobots are taking over that task for people, reducing fatigue and improving overall efficiency. Um, Another one that we see too is welding and soldering applications, and kind of in line with that is polishing and deburring as well. So since these processes require a really steady hand and consistency, cobots are helping maintain that quality while keeping human workers out of harm's way. Obviously, deburring and then welding can have some risks to them. And it's also kind of hard to keep people in those positions, before they find something else. So it's a good place to have a collaborative robot step in and help you out. So all of these examples show that I have listed here: gluing and bonding, inspection, palletizing and packaging. They show that cobots just aren't about automation. They're about making work easier, safer, more efficient for people across a variety of industries. And with that, I'll go ahead and toss it over to Matt to talk about some real world use cases and success stories and show you guys some videos.
Awesome. Thank you, Stephanie. Hello, everyone. For those that don't know me, my name is Matt Langdon. I am one of the engineers here at Doosan Robotics Americas. So to start, let's expand a little bit about what we went over in the first part of this series, specifically for safety. We briefly went over some standards that you should familiarize yourself with if you're interested in using robots or cobots in your facility. A fundamental understanding of robotics safety is also a great starting point for evaluating your system integrator, your product provider, or your distributor, as these parties should be able to give you the answer to any questions you may have about maintaining a safe work environment. As a quick note, in the previous session, Jesse mentioned ISO 10218 and ISO Tech Spec 15066 as two separate documents. However, as of last month, there is a new safety standard. Now it's ISO 10218-2025, like the year, which combines both of those documents into a single source. So I highly recommend, if you are interested in learning about robotics and specifically robotic safety, go out and purchase a copy of ISO 10218-2025. Also, in the previous series, we also mentioned that a cobot does not operate within applications on its own. It is part of a defined system, which includes peripherals like a PLC, end-of-arm tooling, and like its environment, the what, when, and who it's working with. So let's zoom out a little bit. If we consider the end user's facility as a small planet in which the work processes are divided into 4 different ecosystems, each with potential for automation. Next slide. There we go. Perfect. The result is 4 quadrants. So we can do this by dividing the screen here using 2 major axes, speed and payload. So for our case, we will consider high payload tasks, which require moving items that are heavier than 50 kilograms or about 110 pounds. And then we'll consider fast speed as something that's faster than 2 meters per second. So for perspective, an average human's walking speed is around 1 meter per second. So we're double our walking speed in motion. And most facilities, most warehouses restrict a single person from lifting more than 50 pounds. So we're looking at, double the speed and double the payload of what would be acceptable by a normal human. So continuing on the theme of comparison against other industrial robots, we can consider traditional industrial robots like Delta robots and Scara robots as different species of robots, and each have a place on these quadrants. But none of those aforementioned robots were specifically designed to target lower speed and lower payload tasks, which are what humans still need support with in facilities. And that's where the Cobot comes in. The Cobot is designed to support humans in low speed, low payload processes. One of the most common pitfalls in identifying potential implementations of cobots is trying to target a process which already has a better suited species of robot to tackle the task. So the cobot species shouldn't be perceived as a competitor to other species of robots. It should instead be thought of as a symbiotic and able to exist alongside other forms of automation. So where do cobots live? While other species of robots remained caged, we can expect to find cobots in the wild outside of their cages. They've been granted this freedom through their force sensing technology, which we reviewed in the previous series. We can find them coexisting and working alongside other forms of fixed automation, such as CNC machines, packaging machines, conveyors, and other robots, and of course, alongside humans. Lastly, due to the smaller footprint of cobot solutions, we can find them also crammed in spaces that weren't originally designed for robot automation. All right, so peripherals and end-of-arm tooling, or end effectors. So when it comes to end-of-arm tooling, you have the same technologies available to you as you'd have with any other types of robot. When we look at grippers specifically, we most commonly see pneumatic and electric grippers. Pneumatic grippers require a compressed air supply, which most manufacturing facilities already have. On the other hand, electric grippers are a great alternative if you don't have access to air or you need additional sensitivity that you can't find with pneumatics. So in general, pneumatic grippers are stronger, but an electric gripper might be best in a scenario which requires additional precision, as they can they commonly come equipped with built-in microprocessors, which allow you to vary the force, the speed, and the travel of the gripper. So here we have some images of cobot specific grippers. The major thing, aside from just payload and grip strength, is to ensure that you've selected a gripper that is free from any sharp edges. This is to avoid cutting a human in its workspace. I really like the grippers which have padding and high-vis reflective material. That allows us to be more attentive to the end effector's travel path, and it also provides some additional protection in case of a collision. So other types of peripherals. So with PLCs, many customers already have PLCs in their facility, whether you know it or not. Before you choose a collaborative robot, you should always look into or inquire about which forms of industrial communication your PLC uses or that you're accustomed to, and whether or not it's a standard offering or requires like a paid software and hardware piece. So vision. So when performing pick and place operations for work pieces that aren't always in the same place every single time, you can use a 2D or 3D vision system. So vision systems can be used for, at its basic level, inspection. You just have the camera on the end of the arm and the robot moves around and takes pictures. And another note on vision is that this can sometimes be the most complex part of an integration project just because of communication with the camera, and there's kind of a lot of moving parts. The last image there is related to safety scanners. So many collaborative applications have safety scanners. It's kind of a standard offering. Usually you want to have 2 to 3 because they enable the solution to operate at high speeds while an operator is not in the area, and then when the plane is crossed, you can switch to a collaborative speed or even pause the robot when a human comes within range. So these are usually easy to set up with pretty straightforward intuitive software. And these can either be connected to the robot directly, to the robot controller, or using a PLC or even a safety controller. And again, you should kind of check with which types of communication and products that are available to you. Of course, all of these peripherals make up a part of your robotic system. So be sure to talk to your manufacturer, system integrator, and dealer to make sure that safety is always maintained and at the forefront. So this next slide, we just talked about the robot and all these pieces of equipment we can use and connect to the robot. So how's that done? That's where the system integrators and the integration process really comes into light. So all manufacturers will provide some form of documentation and API to make things communicate. How is my product talking? In other words, some will provide example code which will usually really expedite your development because you have something to reference when you're performing the integration. And where we're moving into now and in the future is the real easy to use products which have a plugin or an app, which you just download to the piece of either your laptop or the robot itself. And that offers a simple UI where you're typing in the very basic information to make things work. All the work's done for you, essentially. And that can take your integration project from weeks or months down to hours. All right, so in the previous series, we elaborated on the 2 technologies that allow cobots to detect collisions. They were current control and joint torque sensors. The latter being the most sensitive and the most technologically advanced. So, however, we also stated that it allows for unstructured motions. So what does it even mean? When robots are programmed, they're usually position controlled, i.e. you're telling it which points in space to move to, but there are also tasks that aren't necessarily that simple. So having a software feature such as compliance control and force control allow you to move it allows for dynamic path deviation based upon external force interaction. So compliance control essentially allows the robot to operate like a dampened spring or like a strut on most cars. It has a spring and a dampener built in. So a demonstration utilizing these features would be placing a gear into an assembly when the teeth don't match or mesh. So this doesn't just require motion in the downward direction, because if the teeth aren't aligned perfectly, the robot will fault out due to a collision. So a robot that is able to perform force control can oscillate the teeth and make sure they're aligned, and then continue downward motion. Let's watch another short video demo that shows how force control can be applied in conjunction with compliance control to applications like sanding and polishing. So in this video, the polishing pad is able to deviate from its linear path, so from point A to point B, which is normally just a straight line, while also maintaining that constant even pressure against the plane of the product. So this is what allows us to maintain that even, consistent output from the robot. Just let it finish. Awesome. All right. So like I mentioned, the vision peripheral slide. Currently, managing the QC process is very difficult in the real world when performed by skilled labor. When adding in a robot, a camera, and software to compare against good products, all but guarantees uniform product quality. So this application manages the end-of-line final QC processes and stores the data indefinitely for both real-time QC comparison and for historical reference. We are kind of labeling these videos as easy, medium, and difficult based on the components and time for integration and implementation. So again, this is just one robotic arm with a camera on the end, and how long it takes to develop the vision software kind of changes the difficulty. So bumping up to another application, we have like a dispensing application. And dispensing is kind of a broad term. In this video, we have gluing, but you can also think of kind of welding, painting, any type of motion that's predefined and you're applying a product. So typical problems associated with gluing arise around the application of the dispensed product. You can have too wide, too thin, too heavy, or too light of an application. So this is something that can be improved with automation, as you can vary both the dispensing speed and the robot velocity dynamically to ensure reliable, repeatable processes. And again, this is somewhat of a minimal difficulty level just because you're having to time the robot motion and end start with the dispensing start and stop as well. So for our next video, we have machine tending. This is actually an example of a solution that can be found in the market today, a prepackaged solution. And so with CNC machining, the difficulties are with really timing the loading and the unloading of parts. This is also a really good example of a dirty job and potentially dangerous if you have like an unskilled new worker that's having to go in here and move parts in and out. So we have, with a robot, of course, we can have continuous production. We're also kind of removing the bottleneck from at the machine to the loading and unloading of the robot system. So it's a much safer, simpler task to just load up a tray with blank parts, and then of course unload the tray of finished parts. And so yeah, this allows the worker to focus on tending the robot, which is inherently safer, and not the machine, which is inherently a little more dirty and dangerous. All right, so okay, next application is welding. Again, this is another example of a solution that is in the market and ready to go as a prepackaged solution. So with welding, I mean, it's usually some of these make sense, but consistent weld quality with high mix and low volume operations is very common. This solution prepackages the robot arm, the end of arm welding tool, which is end of arm welding torch, and then you can change out your power supply based on your product and needs, and then it also is all installed on this big old steel table, which allows for various different types of welding. Various different types of parts that you can weld. And again, there's a lot of communications that are going on in the background between the robot arm and the welding torch as well. Cool. All right, next application. This is also a good example of prepackaged solution, and it's palletizing. So one of the easiest, actually shouldn't say easiest, but easy to understand applications is palletizing, because we're picking from a single point and we're placing on a pallet, and we're just creating an array of place points. So as far as palletizing goes, manual labor and the ergonomic challenges equate to higher turnover in the workforce. Because essentially, who wants to move 50-pound boxes all day in a warehouse environment. So what's nice about this system, of course, is we can allows for deployment in at sometimes minutes, depending on how accustomed you are to it, and also redeployment within the same building is easy, especially as this example has casters included on the system. So you roll it up to a conveyor, program the product, and let it stack. And then, of course, you can go to another conveyor and let it stack there as well. Let's see. This system also exemplifies the kind of the easy to use aspect that we're always preaching here, with minimal end user configuration requirements, and then it also has a really nice HMI, which allows operators to set up their product size, and it also includes the nice color-coded start, stop, and resume buttons, which allow for kind of the easy to interact with operation. All right, next application. So this is also an example of a prepackaged solution, but we're adding a few more components. So with sanding, consistent. Oh, I think we just lost the slide. Bear with us for 2 seconds.
Sorry, everybody. My computer decided to switch around, so hold on really fast.
No worries. Apologies, guys. This is a good time to think about questions. Oh, here we go. So for sanding, with woodworking, consistent uniformity and sanding coverage, and the quality of the work done is extremely important. So this solution showcases advanced use of vision and AI to determine both the product placement and the path planning. So this is kind of showing here like the various ways we can sand the same product. So it uses a camera to take a picture, and then it uses a graphics card to create hundreds of thousands of little place points on that product. This also uses the robot's torque sensing capabilities to know, to adjust for any undulations in the product, because again, sanding flat surfaces is one thing, sanding a varying product can result in high spots and low spots. This application is also easy to incorporate with sanding and deburring. All right, magazine loading. So this is one of the most complicated applications we're showing here, mainly because we're doing the reverse of palletizing. So with fast-moving packaging machines, currently people are loading these things with flat packs. So we're using a cobot here, a vision sensor, and a multi-tooled end effector to load this machine. So we're using the arm to maintain constant attention and appropriate feed levels to the machine. So just as with palletizing, this requires picking the heavy flat packs, which are 20 to 40 pounds, on a regular basis. So the cobot can account for the various deviations and variations in pallet kind of shape. So the pallets get moved around a lot, and the point that the product we're picking changes every single time. So we're using the vision system and the sensing technology of the robot to find out where those products are. All right, on to the next one. And so for this one, we'll let the video speak for itself, if we have audio on it. Awesome. And that is it for my part. Thank you, everybody, for listening to me. And I'm going to throw the mic back over to you, Stephanie.
Hey, everybody. So thank you, Matt. Thank you for running through some of those applications. And essentially, we wanted to show you guys those videos because we can talk about it and we can explain the application, but sometimes it's a lot easier to just see exactly what it is and the many facets in which they can be applied. Really cobots right now are a limitless frontier in a way of innovation. So just think if a human arm can do it, a cobot can do it. And how can that supplement your environment, your workforce? And with that, we'll open it up to questions. If anyone has anything, you can either drop it in the chat or ask us after the fact if you prefer. I think our email addresses were on the front. And then, of course, everyone knows how to get in touch with Mike, who can, of course, relay any questions that maybe you're not comfortable asking in here or that you think of later on. So with that, I do want to say, I just want to remind everybody that this is part of a 3-part webinar series. And we've got one more exciting session coming up in 2 weeks. So on March 20th, we'll do part 3, which is looking ahead, trends and innovation in collaborative robotics. In that session, we'll talk about the latest advancements in cobot technology, emerging trends in automation, and then what the future holds for collaborative robots. So if you haven't already signed up, please do. You can sign up by visiting the Manufacturers Association of Maine webpage and then clicking down under events. Or I think if you are signed up for this, you might have the entire series, so you may already be signed up. But I hope we do see you for that one. And so for us, that's all for us today. We really appreciate you taking your time to join us and hope that today's discussion was insightful. Hope it was inspirational. Hope it got you thinking about how you can work with cobots in your environment. And also a big thank you to the Manufacturers Association of Maine for hosting us. And of course, to all of you for your time and management and engagement. Sorry. For joining us today. We really appreciate it for taking the time out of your busy Thursday to hear about cobots. So hopefully we'll see you in 2 weeks for our series on March 20th.
Excellent. Thank you, Stephanie and Matt over at Doosan, and thank you to the team at Industrial Automation Supply. We will see you in 2 weeks on March 20th.